Okay, so now we're on to factoring. So when we look at factoring, that is the opposite of what we just learned about, so expanding. Um, so if we look at the example here, I'm going to make this a little bit bigger. So if we look at our lesson, so our learning goal will be how to factor using common factors. So I'm hoping this is a bit of a review for you. You should have done this in grade 9 as well as grade 10. So factoring is the opposite of FOIL. So remember that FOIL is first terms, outer terms, inner terms, and last terms. So you're doing that kind of rainbow effect. So if we look here, we have 5x plus 7. So that is the factored form of our 5x. Oops. Our 5x plus 30 right here. So here we are expanding, so our FOIL. It keeps changing over here to typing. Okay, so that is expanding, and to go the opposite way is factoring. So when we look at the word factoring, we see the word factor. So factors are numbers you multiply to get to another number. So for examples, the factors of 15 are 3 and 5, because 3 times 5 equals 15. So if we look at our other example, so I'm going to erase this. So we've got example 1 here for you guys. So what are the factors of the following? So we've got Molson in the background here who's going to make a ton of noise for us. So if we look at 24, we're going to look at the two numbers that multiply to give you 24. So we're going to have 1 and 24. We have 2 and 12. 3 times 8 is going to give us 24, and 4 times 6. Okay, so those are our factors. We're going to do the same thing for 20. So 20, we're going to look for two numbers that multiply and give us 20. So 1 and 20, 2 and 10, and 4 and 5. And that's it. If we look at x squared here, so remember when we were expanding, there was that little invisible 1. So if there's no number in front of our variable or as our exponent, just think of it as a 1 being there. So we're going to think of our coefficient first, so that number that's in front of the variable, so the letter. So we have 1, so 1 times 1. And then x squared is ultimately x times x. And that's our answer for that one. If we look at 6a squared, so we're going to look at the coefficient first. So what two numbers will multiply to give us 6? So 1 times 6, 2 and 3. And then we have our a squared here, which is the same thing as a times a. Okay, so the greatest common factor is the highest number and variable. Oops. That divide into all terms. So the greatest common factor, so GCF, may be a constant, which in other words is just a number that doesn't have a variable to it. A variable, so our letters, such as X, Y, or A, or both. Okay, so I'm going to clear this and we're going to look at example 2 here. Okay, so we're going to find the common factor for 6x and 24. Okay, so here we're going to look at the number again, so the coefficient. So for 6, we have 1 times 6. We have 2 times 3. and we just have one x. If we look at 24, we have 1 and 24. We have 2 and 12. We have 4 and 6. And 3 and 8. Okay, so when we look at this, so make sure that you make it clear that you separate the two. And what you're gonna do is you're gonna look for the largest number that they have in common. So here they have 6 that are both in common. Okay, and they don't have both x, so 6 is our greatest common factor. And that's it. If we look at 10x squared and 15x, so we're going to do the same thing. So look at the coefficient. So two numbers that multiply to 10. So 1 and 10, 2 and 5. And we have x and x. Same thing on this side. So 15x, we have 1 and 15. We have 3 and 5 and just 1x. So we're going to look at the numbers first. So which number do they have in common that is the greatest, that is the biggest? So we have 5. And then we have 1x. That was an awful circle. So that means that our greatest common factor is going to be 5x. Sometimes, and I'm hoping by the end of this, you won't have to think so much about it or do this list. Like I'm able to look at these numbers and say, okay, the greatest common factor is 5x. I don't need to make a list the way that I am right now. And that's okay. You don't have to prove it to me at all what it is, because once we get to the greatest common factor, you won't have to write it out this way. But if you do need to, go for it. So our first term, we're going to look at 6x cubed. So we're going to have 1 and 6, 2 and 3, and then 3 x's. Here we're going to have 12. So that's a negative 12. So we're going to have 1 and negative 12. We can have negative 1 and 12. So it doesn't really matter the negative at this moment, unless all three of them also have a negative. We have 2 and 6, and we have 3 and 4, and we have 2 x's. And we're going to look at 18. So we have 1 and 18, 2 and 9, and 3 and 6, and 1x. So we see here that they all have an x in common. Okay, and the largest number would be 6 with all three. Okay, so our common factor is 6x. Okay, so the steps for common factoring would be to determine the greatest common factors, our first step, between all of the terms. And it has to be between all the terms. Even if there's 3 terms or 4 terms, you have to find it for all of them. If you have the same variable in each term, take the smallest exponent. So as you can see here, they all had x in common, but we were only able to take one x out. So that means that x to the exponent 1 is our common variable with those guys. And they do have to be the same letter. You can't have like y and x and think that that's the same. Write the greatest common factor in front of an open bracket, and then divide everything inside that bracket by that common factor. So I'm going to let you guys type that out. Apparently Molson needs to go out, so I'm just going to pause this real quick and we will keep going with the lesson. There's just 2 more examples to do. Okie dokie, I'm back. So I'm going to clear this sheet and we're going to move forward. I did realize that there's a 4th step on the next page, which you don't need to do unless it's stated otherwise. So our 4th step would be to check your answer by expanding. So by doing FOIL. Okay, so if we look at example 3, so common factor the following, check your answers by expanding. So again, if it says that, then do it. Otherwise, you don't need to unless you feel the need to. Okay, so we've got 10x minus 15. So 10 and 15 have the common factor of 5. There's no variable that matches between the two. So all we're going to do is write the common factor here. So the common factor being 5, open our bracket. You're going to do 10x divided by 5, which is 2x. The same sign goes in the middle. 15 divided by 5 is 3, and then close the bracket. Okay, so for us to check, we're going to expand. So you're going to do 5x times 2, or 5 times 2x minus 3. And you're going to do our little rainbow here. So 5 times 2x is 10x. 5 times negative 3 is negative 15. So it's good. Here, we're going to look at the two numbers. So we can tell that there's the common factor of 2 at least. Is there 3? You can't divide 20 by 3, but you can divide 12 by 3. Is there 4? So can we divide 20 by 4 and 12 by 4? Yes. Okay, so 4, and they both have an x. So we're going to take the one with the smallest exponent, which is right here, so just 1x. Okay, you're going to open the bracket. You're going to do 20x divided by 4x, which is just 5. Same sign. 12x squared divided by 4x will give us 3x. And close that bracket. So here, x cubed plus 2x squared. So there's no coefficient in front of this one, so there's not going to be a number. All we're looking at is the variables between the two. So we take the one with the smallest exponent, which is x squared. So we're just going to take x squared as our common factor. X cubed divided by x squared just leaves us with x. And then 12 and x squared divided by x squared, there's nothing left. Okay. So I'm going to erase that, and we're going to do one last example, and you are on your own for practice questions, and there's one more lesson after this. So I'm clearing this. Okay, so factor a trinomial by finding the greatest common factor. Check your answers. So we have 3x squared minus 9x plus 12. So a common number between the two would be, or between the three would be 3. So 3 can be divided by 3, 9 can be divided by 3, and 12 can be divided by 3. Because that last 12 at the end here doesn't have an x, we're not adding an x to our greatest common factor. So 3x squared divided by 3 is x squared. Same sign. 9x divided by 3 is 3x. Same sign. And then 12 divided by 3 is 4. That's it. Oh, and I forgot to check the other ones. Oh, poop. Okay. So we're going to check this one out. Okay, so you're going to expand, so you're going to do 3 times x squared, which is 3x squared. 3 times negative 3x, which is 9x. And 3 times 4, which is 12. So our answer is right. Okay, here we've got, first of all, it's best if we take the negative away from the very first term. So we're going to say that our common factor has a negative. We look at 4, 12, and 8. So they all have a common number of 4. And they all have the variable x. And the smallest one is x to the exponent 1. So that's what we're going to take out. So negative 4x cubed divided by negative 4x is just x squared. So because we're taking out this negative, all of our signs are going to change now. So this is going to be a plus. 12x squared divided by 4x is going to be 3x. our sign's going to change because we take out the negative. And then x or 8x divided by 4x is just 2. And we close that. So to check, we're going to expand. I think I'm getting a hang of this tablet here. So negative 4x times x squared is negative 4x cubed. Negative 4x times 3x is negative 12x squared. And then negative 4x times 2 is positive 8x. And so the reason why the signs change is because when you multiply a negative by a negative, it gives us a positive. So it's going to give us this. If we do a negative times a positive, it gives us a negative. So it brings us back to where we were. Hopefully that makes sense for you guys. If not, message me and we